Hello everyone, this is DSS Zindabad and today we are going to discuss the daily challenge of Leetcode. The question is determine if the string halves are alike. The problem statement says that you are given a string S of even length, split the string into two halves of equal length and let A be the first half and B be the second half. Two strings are alike if they have the same number of vowels. And we know what are vowels, A, E, I, O, U, both in capital as well as in small letters. Notice S contains uppercase and lowercase letters as I've just discussed. We need to return true if A and B are alike, otherwise we need to return a false. So we understand that what have we given in this problem, that we are given a string S and it is a combination of both the capitals and the small letters. Okay, and from this what I need to do is I need to divide S into two parts, S1, S2, assuming that if S was of length n, then both of these will have n by 2 alphabets in them and the number of vowels, that is A, E, I, O, U, needs to be equal for us to return true. So guys, this is the problem statement. It is a very easy problem. So let's jump into the approach. Talking about the approach, what I can understand is that here, though my string S contains both, that is the consonants and the vowels. Consonants are the general alphabets except for vowels, that is B, G, D, P, Q, etc. And vowels we know we have 5 vowels in English, that is A, E, I, O and U. Right, we have 5 vowels. So my first thing that I need to particularly understand is that I need to somewhere store these 5 vowels. So what I can do is I can have a data structure in which I am storing my vowels, because what I need to work with this is only vowels. It does not matter how many consonants you have in the string. If you do not have, it does not matter. What matters is the vowels. So we need to specifically store these vowels in a data structure. For that purpose, you can use any data structure like set or an unordered map. Why we will be using these? You can even go for a vector, right? Why we'll be using this is because we have the find time complexity of O of 1, right? So that is why we'll be using set or unordered map. So let's talk about, okay, we've understood that we need to store these. Why? Because we might need to know that if I am traversing on my string S1, right, which is a part of S, which is the half part of S, right? I'm traversing on this string and I have something like, say, F, A, R, G, E. So if I'm here, is F a vowel or not? That if F is a vowel or not, because it will directly affect the number, right? So I'll say F does not lie in this data structure. For example, I'm using set. So I can simply use the dot find function here, right? I'll say it's not there. So move on, do not increase the count of number of vowels for the first half, right? And similarly, when I come to A, I'll say yes, it belongs to the data structure, because in the data structure, we'll have A, E, I, O, U. So we'll say yes, it is here. So increase the count. So when I talk about this, we understand that the second thing is, alongside storing this is, we require a count variable, right? We can have like two count variables, count 1 and count 2. Count 1 can basically be for the first half, right? The first half of the string, let that be the A part, and second half of the string. Okay. So after this, there's a very important thing that we need to understand, and that can be tackled in two ways, but let's discuss what it is first. Here you can see that, notice that S contains uppercase and lowercase letters. So it is, the problem statement is saying that whatever string S has been given to you, it has both the uppercase and the lowercase letters. So I can basically tackle this particular thing in two ways. The first way can be in my data structure, which I just mentioned above, alongside these elements, I can add the capital version of them too, right? Or what I can do is, this is the first part, that add in the capital vowels in the data structure, right? Or in the second thing that I can do is, I can simply go for something like a transform function, which is present in the C++ STL library, right? Basically, the transform function further gives you two different kinds of it further gives you two different functions, that is to lower or to upper. So these two functions, what do they do is, you'll give them a string as an input, right? And for example, that string str was something like A, B, C, D, E, F, right? And I want to convert it to lower. So it will convert this string, and as the output, I'll have everything in the lower case. And similarly, this is the very similar case for upper, that if this string was given to upper in the transform function of the STL, it will make everything in caps. So this will be the output. For transform to be used, the time complexity is O of n. I have added the link to the GFG article for the same in the description. You can go through it once. Okay, so I feel we have discussed the approach in quite detail. Now, what we'll do is we can, so I think I've discussed the approach in quite detail, and the problem is very easy. So let's quickly use one example to have a dry run. Okay, so let us assume this is the string that has given to me, that is textbook. Here, they have given everything in lowercase only. So that is okay. But you might have something in which you will have a combination of both lowercase and uppercase. So in that condition, you can use the two methods that were given above. So for discussing that approach, let me quickly change a few things. Let's use this textbook, right? Rather than this example, I've modified it a little bit for us to understand. So what I'll do is I'll quickly make a data structure, right? For the purpose of you to understand the transform function, what I'll be doing is I'll be, rather than adding the capital version of the vowels, what I'll be doing is in the data structure, in my set data structure, I'm just adding the lowercase, and I'll in the further processing, I'll be using the transform function to transform whatever string has been given to me into lower case. Okay. So this is given to me. What I'll do is I have these in my set data structure. I'll simply use two loops, right? First of all, let's figure out what is the length of this string that has given to me. The length is 8, right? So that means for the first four alphabets, that is text, and the last four alphabets, I can run the loop twice, and I'll be iterating over them separately. So that means text book was given to me. After applying the transform function, which is the STL function, I'll have everything in lowercase, right? So now this is the string in consideration, which is text and book. So here for the first part, I'll simply run a for loop that would be from 0 to whatever is the length of the string by 2 I plus plus. This is for this part, the first half. Okay. So what I'll do is I'll simply check that, okay, so text is what I'm working with, 0, 1, 2, 3. I'll simply say that you have to check that if you find it in the set variable, so let's call it something like vowels, that let's call that set data structure, let's name it as vowels. So if vowels dot find as s dot I, right? In that case, I can have a count variable, count1, where let us assume count1 was initialized to 0, right? We'll increase the count, else we'll just move forward. So I am on the 0th index. It says T. I say, okay, my set data structure, do you have T? It will say no. So I'll say, okay, that means it is not a vowel. Let's move forward. I come to the first index, we get E. We say, yes, E is a part of the data structure. That means it is a vowel. So we'll increase the number. So count becomes 1. I move to the next index. X is not present in the vowel set data structure. We'll move forward. T is again not present. We'll move and this for loop terminates. Next, for this half, the second half, what I'll do is I'll again have another for loop. Here, the pointer would be starting from s length by 2. And we'll say while it is less than the length of the string and you increment it. And for this purpose, I can have something like a count variable 2, which is initialized to 0. So now this part is computed. We'll come to book. 0, 1, 2, 3. These are the indexes. I am on B. You say, is B present in my vowel set data structure? No, because it is a consonant. It is not a vowel. I'll go to the first index. It will say, oh, yes, it is present. So I'll increment the count 2 by 1. Then I'll move to the next index. O is again present in the vowel data structure. We'll increment it again. It becomes 2. And then we come to K. Now, on third index, as K is present and K is not a vowel, so it is not present in my vowel set. So, we'll simply come out of the loop. At the end, what we can do is we can simply say that if count 1 is not equal to count 2, in that case, it means that the number of vowels in the first half of the string S is not equal to the number of vowels in the second half of the string S. So this was the dry run. I hope this is clear. You can do it in the other way also, rather than using the transform function, which I have used here. What you can do is you can simply add in the capital values, right? So now let's quickly code up both the approaches and then I'll tell you what is the difference in the time and the space complexity. Okay, so this is the question. What I'll do is I'll simply compute first of all the length, right? I'll use a set data structure and in that I'll be storing the character and let us name it as vowels as we did in the approach. Now what I'll do is I'll simply insert the vowels of the English language, that is A, E, I, O, U. I'll quickly copy paste this. A, E, I, O, U. And now what I'll do is I'll simply create two variables, that is int count1, that is initialized to 0, count2, that is again initialized to 0. We'll run the first for loop, that is I, and it is less than n by 2, I plus plus. And I'll simply say that if vowels dot find, which is the set data structure, in that if you find whatever is present in the index value of the string S and that is there in the vowels set, so in that case it means it is a vowel. So you will simply increment the count 1 and I can use this similar loop for figuring out the number of vowels in the second half of the string. Just I'll simply change the for loop conditions here, right? And here we'll make it count 2. And then we can say that if count 1 is not equal to count 2, then that case you return a false, else you return true. Let's quickly run this code and see if it is working fine. Yes, it is. Now let's submit it. Okay. So here, as you see, we missed one very important step that we discussed. So let's quickly use the transform function before figuring out the count. What I'll do is I'll use the transform function of the STL, and I'll give it the parameters s dot begin, s dot end, s dot begin, and then I'll make it to floor. Let's try it for that case that we failed so that we know we've done it right. And it is working. Let's submit it quickly. Okay, and it is done. So this was the first way of doing it, right? Now let me quickly tell you how we could have done it in another way also. Here, I'll simply comment this out, right? And alongside adding these, I'll also add the capital versions of the vowel. So it goes like A, capital E, capital I, capital O, capital U. Now let's run it again and let's submit it. And it works just fine. So both of these codes have the similar time and space complexities, right? So I'll quickly copy paste the code for us to discuss it further. Okay, so these are the two codes that we worked upon right now, right? So let's discuss this code first, right? Here, what happens is we're using a set data structure, but it is only storing 10 values, right? So it becomes the space complexity becomes O of constant, which is equivalent to O of 1. When we talk about the time complexity, as we're running these two loops, but again, it depends upon the length of the string. So it becomes O of n, right? So this is the time and space complexity. Talking about this approach here, again, we've added constant vowels in the data structure. So it is O of 1 space complexity. For transform function, it is O of n. And for these two loops, again, the time complexity is O of n. So the time complexity is O of n and the space complexity is O of 1. You can use any of these approaches for solving the problem. Thank you so much for viewing the video till the end. Please like, share, and subscribe. Thank you.